Okay, this is chapter 8.3. We're going to talk about direct variation and joint variation. So we want to figure out what the relation is between two items so that we can apply that to something else. So there is a green box here with some steps. Establish two pairs of related data. So typically we have both pieces of information in one pair, but only one piece in the other pair. That gives us a way to solve for something that we're missing. Okay. We are going to make sure that like items are in the numerators and like items are in the denominators. We're going to use those two ratios to form a proportion that we can solve. So let's take a look at example 1. We love the application problems, okay? So I'm just going to go with how it reads. So I have 7 cans of dog food, costs $4.13. That's going to equal my other proportion. 10 cans has to go in the numerator because the 7 cans is also in the numerator. I'm solving for X dollars. Now, this is the way I set it up because this is the way I read it. I am allowed, because it is a proportion, to flip things over. It's a little easier when the X is in the numerator. So all I have to do now is multiply both sides by 10, and then we're going to multiply 10 times 4.13. We're going to divide that by 7, and I get X equals 590. I didn't leave a ton of room here, so organization has kind of popped back and forth. Sorry about that. So if 7 cans cost $4.13, 10 cans is going to cost $5.90. Okay. B, I have 2 gears that have a ratio of 9 to 4. Again, 9 to 4. The larger gear has 108 teeth. We're solving for the teeth in the smaller gear. So again, I'm going to flip these over. X over 108. 4 over 9. It's just a little easier to solve when that X, that's a 108, is in the numerator. Does not really have to be. And we are going to get X equals 48 teeth. Okay, the last example here. I've got a person weighing 185, should be given how many milligrams? So I'm going to go ahead and try to set this up this time with the X in the numerator. X milliliters for 185 pounds. The dosage is 15 milliliters for every 10 pounds. So 15 milliliters for every 10 pounds. Again, milliliters, milliliters, pounds, pounds. I want the X by itself. So I've got to get rid of the divide by 185 part. We multiply by 185 on both sides. And we get that X equals 277.5 milliliters. So you need the ratios, the corresponding ratios. We're going to set it up. We are making sure that like items are in the same place. So here we had cans in the top, dollars in the bottom. Here we had the larger gear in the top, smaller in the bottom. Here we had milliliters in the top and pounds in the bottom. Okay. Sometimes we're going to be asked to find the constant of direct variation. That just means it's kind of like a unit ratio. something to 1 per. Okay. So we have chlorpromazine injection strength contains 15 milligrams per 2 milliliters. Okay. A patient is prescribed 0.5 grams. We want to know how many milliliters should be administered. So I got 0.5 grams. We're going to go back to what we did with the dimensional analysis. I want to go from grams to milligrams. So 1 gram is 1,000 milligrams. And we know that this is 50 milligrams per 2 milliliters. 50 milligrams, so my milligrams cancel, per 2 milliliters. 0.5, and I'm going to write this out, times 1,000. We're going to multiply everything in the numerator, times 2. Our label is going to be milliliters. That's what we have left. Divided by 50. Once we multiply everything in the numerator and divide by 50, we get 20 milliliters. Okay. That really should have been attached to a, Sorry, it wasn't really a constant of variation, but B is. Bottling machine can fill, with 2 L's, 800 bottles in 2.5 hours. Find the constant of direct variation. This is what we're looking for. Number of bottles filled per 1 hour. So basically, if I can fill 800 bottles in 2.5 hours, we're wondering how many I can fill in 1 hour. That's a straight division. We're going to take 800 and divide by 2.5, and we get 320 bottles per hour. The constant of variation is always per 1 hour, per 1 mile, per 1 hiccup, whatever we're talking about. Okay. We can have a joint variation. It just means that something varies with 2 other things. Okay. So here, if X varies jointly with Y and Z, X varies jointly, here's my constant of variation. With Y and Z. We want to find X, Y is 18, Z is 20, and our constant of variation is 3. So straight multiplication here, 3 times 18 times 20, and X equals 1,080. Last example here, find the simple interest. We had the interest formula in the last section. Interest equals principal times rate times time. Okay. Interest varies jointly as R and T with the principal P as the constant of variation. Here's our equation. Constant of variation is P, R, and T. We vary jointly. Okay. So we want the simple interest on a principal of 8,000. The interest rate is 6%, which we write as a decimal. Time is 5 years. So take a minute to write that. And our simple interest after 5 years is $2,400.